Today we begin Unit 3. We will be looking at our introduction to scatter plots. Today's lesson will be more paper and pencil. When we begin tomorrow's lesson on 3.2 is when we will introduce the calculators. Today you're going to learn how to look at and analyze scatter plots by hand. So your objective that you are writing in your notebook says, I will be able to identify and describe different types of correlations and determine if a correlation results in a causal relationship. That does say causal relationship. That's not a casual relationship. So take a moment to write that objective down. Pause if you need to. When you're ready, move on to the next slide. In your notes, I'd like you to write the definition of what a scatter plot is. A scatter plot is a graph of plotted data points that shows the relationship between two sets of data. So there will be the independent variable on the x-axis and the dependent variable on the y-axis. When you have that definition down, go ahead and move on. The next thing I'd like you to write is a title that says linear correlations. And once you have the title, I'm going to give you a preview. You're going to draw a couple quick scatter plots. When I say quick, that means you're just quickly going to draw the first quadrant. Just to give you a visual or idea, this really is the coordinate plane with the 4 quadrants, but we are just focusing for right now on the quadrant 1, the upper right. I'd like you to draw a quick graph that shows a strong positive correlation. It is strong because all the points seem somewhat close together. Sorry for the interruption. You'll notice on the stronger positive correlation, it's positive because it's a rising line. If we were to estimate a line of best fit down the middle of the data, it looks like it's a rising line. So that's where the positive comes from. And it's stronger because the points are closer together. If you look at a weaker positive correlation, it still looks like it's a rising line if I were to draw a line of best fit. But do you see how the points are more spread apart? So the closer they are to a straight line, the stronger it is. The further apart the lines are, even though it's still positive, it's a weaker correlation. So take a moment to draw both a strong and a weak positive correlation. Once you have those two examples down, I would like you to draw a strong negative correlation and a weaker negative correlation. So instead of rising, this one would be falling. And when you draw your dots, they're kind of close together, but they are going in a descending, like a negative slope. A weaker negative correlation, it still looks like it's going down, but the points are much more spread apart than they are on the stronger one. So I'd like you to make sure that you have all 4 of these drawn, because part of what we're doing today is we're looking at scatter plots that have already been drawn, and we're analyzing them. We're looking at the correlation. How strong is the correlation? Is it strong, the points are close together, or is it weaker, they're further apart? So having these 4 examples in your notes will help you with your assignment later. There are 3 other types of correlations I do want you to draw as well. The first one, which is important, is the no correlation. That means as you look at the points, you can't tell if it's rising or if it's falling. They're just kind of all over the place. So if the points look like they're all over the place, you would simply say that there's no correlation there. The other 2 you may see, but we're not going to do a lot with, is you might see a quadratic correlation, which just means a U-shaped, or you might see an exponential correlation, which is the J shape if it's rising, or an L-shaped one if it's decreasing or falling. So we're not going to do a lot with quadratic and exponential, but I do want you to be able to identify them if necessary. And make sure you do have an example of what no correlation looks like. When you have those 3 done, go ahead and move on to the next slide. All right, this statement is going to sound pretty wordy, but I will explain it. There is a statement that says, correlation does not imply causation. So what we're going to look at now is there might be a scatter plot that shows a relationship it might look like it's a strong positive correlation, but if we take a moment and actually look at the two variables we're comparing, it may not prove that one variable causes another. So in your notes, you are going to write this title, Causal Connections from Scatterplots. This expression right here in red is key. Correlation does not imply causation. Just because it looks like it's a rising line or a falling line does not mean whatever's on the x-axis causes the numbers on the y-axis to change. This will make sense as soon as we see an example. So when you have this statement written down, go ahead and move on to the next slide. Here's what I would like you to look at and then decide how much of this you want to draw. When we look at a scatter plot, the points can be in a perfect straight line. This is a perfect positive correlation. This is a perfect negative correlation. You will see they make a perfect straight line. Each point is rising and running the exact same slope. If it is rising, it would receive a number, a score, of exactly 1.0. If it looks like it's definitely rising, the points are fairly close together, we're going to assign a number around 0.8. You're going to get to estimate here. If you can definitely tell the points are rising instead of falling, but they're spread out quite a bit, you're going to go with a number around 0.3. So you're really going to be estimating between 0, nothing is correlated, and 1. If it's a rising line, you will assign it a number between 0 and 1. The same goes for the opposite with negative. If it looks like a perfect falling line, straight line, that's a negative 1.0 score. If it's coming down and they're fairly closely together, you're going to say about a negative 0.8. If you can tell it's going down, but they're more spread out, it's more of a negative 0.3. So when we go and I ask you to give me a number of how directly correlated it is, you're basically going to pick a number all the way from 1 to negative 1. Nothing will be bigger than a negative 1. Nothing will be bigger than a positive 1. Everything will be in between. So you decide if you want to quickly draw visuals, and the main thing is you attach these numbers with them so you can assign values. When you've decided how much you want to record, you can pause the video or go ahead and move on. Here's our first example. I'd like you to look here. We're comparing the height of something to its weight. You will notice the points are a rising line, so it's positive. The question is, would you say it's strong or weak? And would you say, is it linear, quadratic, or exponential? When I look at it, if I were to estimate a line of best fit, it would be a straight rising line. So I would say it's definitely linear, and it's definitely positive. Do you think that is strong or weak? I would go more with a weak, positive, linear description because the points are fairly spread out as we go. It starts out pretty good right here, but as you move up, the points are spread out. Now here's the next question. Is it a causal connection? Do you think as the height gets higher or bigger, that the weight will also get bigger? So in other words, does the height increasing cause the weight to increase? I would say the answer is yes. Not always 100% of the time, but in general, when something gets taller, the weight does increase. So in your notes, make sure you draw a quick sketch, label it as height and weight, show a weak, positive, linear points on your graph, and then write down the description. Say that it is weak, positive, and linear, and say yes, there is a causal connection. The last part for this question is let's rate how close a line of best fit would be. So let's think about it. Here's another way to look. It is a positive line, so the numbers will be between 0 and 1. We're not going to worry about the negative numbers over here because it's a positive rising line. We said it was weak, so it's not going to be closer to 1. It's going to be closer to 0. So would you say it's 100% straight line, 50% in a straight line, 0% in a straight line? Go ahead and make your best estimate of what number you would assign. If I were going to assign a number, I would say this is probably about a 0.7, 0.8, but if you want to say 0.6, that is fine as well. Here's our next example. Draw a quick graph where you label it as the amount of time spent training compared to the time it takes to run a 100-meter dash. So this is saying as time increases, the amount of time spent training increases, the time it takes you to run is actually decreasing. That's actually a good thing. If your time decreases on a race, that means you're improving. So let's describe it. We know that it's negative because it's going down, and it's linear. It'd be a straight line for the line of best fit. Do you think it is strong or weak? I would go with that it is strong, negative, and linear. I would say strong because even though there's a lot of points, they're all fairly close together. And then the next question is there a causal connection? Does the amount of time spent training increasing cause your time to decrease? I would say yes. The more time you train, hopefully your time improves and gets lower. So what number would you assign to that graph? It's going down, so we're going to pick a number between -1 and 0. You need to think of a number between -1 and 0. It will not be -1. It will be greater than that because it's not a perfect straight line and it's not 0. But we did say it was strong. So I'm going to go with maybe a 0.8 correlation. This is an estimate. You will learn tomorrow how to get this exact number out of your calculator. For right now, we are just estimating. You could say 0.7, 0.8, and you would be fine. Here's our last example. Draw a quick graph. Shoe size. As it increases, does that increase or decrease your SAT scores? Well, if you look, the points are all over the place. There is no correlation. So if we would describe the correlation, we'd say there is none. Is there a causal connection? Does your shoe size increasing cause your SAT scores to increase or decrease? The answer is no. Your shoe size has nothing to do with your SAT scores. So the number that we would assign for how close a line of best fit would fit the data would be 0. There is no correlation. We would have no idea if this would be a rising line or a falling line. So make sure you have the graph drawn and you've said there's no correlation, there is no causal connection, and we would rate the line of best fit at 0. So you've seen a positive correlation, a negative correlation, and now no correlation. That is it for your notes. Your assignment is on Canvas, but there are also printouts of this worksheet located in the front of the room. So feel free to either do it on your iPad, sheet of paper, or go ahead and get a copy.